Hello everyone, welcome back to my channel. We are doing lead code 3439 reschedule meetings for maximum free time 1. So let's have a look at what the problem statement says. It says you're given an integer event time. So you're given this sort of an integer 5. Now what this event time is basically it says that you have an event which starts at time 0 and it goes till event whatever event time is. Alright, perfect. Then what you are given, the second thing which you are given are two arrays, start time and end time, something like this. So, and this is the start time and this is the end time for a particular meeting. Okay, you can have up to n meetings. So over here you have n equals 5 meetings. Perfect. Start time and end time of n meetings, and all of those meetings are non-overlapping. Now what we need to do is we need to reschedule at most k meetings. At most k meetings. And why are we rescheduling the meetings? So that we can return the maximum amount of free time possible after the rearrangement. Alright, now there are some things which we need to keep in mind, and they are that the relative order of all the meetings should remain the same, and obviously the duration of the meetings should also remain the same. What we are looking for is the longest contiguous period of free time. Okay, so let's keep that in mind. Now I have drawn some test cases over here. Event time is given as 5, so we know that the event starts at 0, goes till 5, and then we have two meetings. The first meeting starts at 1, ends at 2, and then the second meeting starts at 3, ends at 5. Perfect. So this is event number 1, this is event number 2. I can very clearly see that there are two gaps. Okay, this is gap number 1 and this is gap number 2 that are there. Now, since k is given to me as 1, I can only modify the place of one meeting. And what I will do is I will swap both of these. I will swap both of these. So what's going to happen is that the meeting is going to come over here and this place is going to become a gap. All right. So let me show you that with curly braces. So this whole thing is going to be a gap. Now, since this gap, the size of this gap is 2, so the answer of this particular test case comes out to be 2 as well. Now another test case, we are given k as 2, but what we are observing over here is that there is no free time at all. So in this particular test case, the answer which you will return at the end of the day is going to be 0. Even if we see the second test case that is given to us over here, the event time is given to us as 10, k is 1, and then these are the starting times and the ending time. So the first event starts at 0, ends at 1, so on and so forth, 2, 4, and then 9, 10. Now the k is given to me as 1. So what I'll do is this particular event which starts at 2 and ends at 4, I will shift it 1 unit leftwards. Alright, now when I shift it 1 unit leftwards, it ends at 3, and then since this particular event ends at 3, the next one starts at 9. So how much gap is between both of these events? The gap is 6. So the overall answer that you are returning is 6. So again, at the end of the day, what we have to do is we have to somehow make sure that we are able to reschedule the meetings in a way that maximizes our contiguous period of gap. So let's think about how we can do this, right? So if we think about it, what we are dealing with over here, our focus should be on the gaps, isn't it? The gaps that are there between the events. We don't really care about when the event starts, when it ends. What we care about is when our current event ends and when the next one starts. We care about the gap. We care about the gap. We don't really care about their timings, their relative position or anything, isn't it? Because gap is the one, the free time is something that we are trying to maximize, right? So what I'm thinking over here is, why not take a vector? Why not take a vector and let's call that vector gaps. Now, what's the first gap that you observe? The first gap that I observe is that my first event does not start at 0. Now obviously, since it does not start at 0, means that there is some free time at the very beginning. At the very beginning there is some free time. So the first free time that I have is from 0 to 1, so I will push back 1 inside of my gap cell. Okay, perfect. Now let's see, the first event ends at 2, the second one starts at 3, so again there is a gap of 1, and then there is no gap after all. So I have the gaps array as 1 comma 1. Now the k is 1, which means that I can move one event either to the left side or to the right side, isn't it? Let's actually pause this particular test case over here and try to think of one which is a bit more complex. Okay, so let's keep this particular test case in mind and let's see how we are going to be processing this one. So the first gap that I see is from 0 to 1 because my first event does not start from 0. So 1 over here, then the gap between both of these is 2, then between both of these is 1, and at the end also, you see, my last event does not end at event time, it ends before that. So what does that mean? I will have a gap at the end as well. So I will have 1 over here. So this is my gaps array, which basically tells me that, okay, you have 4 gaps. Now, what we are trying to do is we are trying to come up with longest consecutive free period, isn't it? So basically, after moving around some one or two meetings, a couple of meetings, or from one position to another, what we are trying to do is we are trying to maximize the consecutive free time. Now, what I will do is I know for a fact that I can move only one meeting from its place to another, right? So which meeting should I pick in order to move it from its position? Should I pick this one? Should I pick this one? Should I pick this one? Now, um, if we start to think about it, we do have choices. I do have a choice whether to move this, or this. So it might trick me. It might say to me that, okay, we can think in terms of recursion. And again, since we are talking about recursion, maybe it can be memoized to become DP. But do we really need to go there? I don't think so. You know why? Because there's an easier way to take this into approach. What is that? You see, I have gaps over here. So let's assume for a second, let's assume for a moment that I choose to sort of move this particular box. Okay, I choose to move this particular box. So when I choose to move this particular box, what I'm going to do is I'm either going to merge it with the next one, or I'm going to put it at the very start, isn't it? These are the only two options that I have. So I'm either going to do this. I'm either going to do this, so the gap becomes 3, or what I'm going to do is I'm going to do this. Now, whatever choice I make, the gap remains to be 3, right? So that means we don't actually have to really move the box. We don't have to actually move the box. We just have to simulate it. And how are we actually simulating it? If you think about it, see, this is a very critical point. I want you to think about it. I don't want you to tell you the answer directly, because it's going to literally ruin the actual learning point that is there inside of this problem. So how am I actually simulating moving this particular meeting? You see, I have gaps in front of me, and right now I know for a fact that there is only k is equals to 1, so I can only move this particular box. Now, what this teaches me is that when I move this box, doesn't matter in which direction I move it, whether back, whether forwards. What I am getting is the sum of these two gaps, isn't it? Because when I merge it with the next box, what happens is that gap number 2 and gap number 1, they become together. Either gap number 1 goes on to join gap 2, or gap 2 goes on to join gap 1. There is no other choice, right? So what's going to happen is both of these guys are actually going to get summed up. Does that make sense? This is actually literally what why I think this question is worth solving, because this was the best part about it, thinking about this particular thing. So when you move a particular box, you don't really have to think about in which direction you have to move. You just have to merge those gaps, right? Now, for a moment, let's say I am trying to I decide to move this particular box. So I can either move it to the front. Now, if I move it to the front, let's say I move it over here. What is the gap that I have? I have 3. And where is that 3 coming from? This one. Let's say I move it to here. Now, what's the gap that I have? I again have 3. What was the original position of the box? It was 4 comma 5. This is gap 2. This is gap 3. When you move this particular box, what happens? Gap 2 and gap 3, they get added up, right? So you have 3 over here. And similarly, if you choose to move this particular box, you have gap 3 over here, gap 4 over here. If you, let's say, if you merge this green box with the blue box, you're going to get gap 3 plus gap 4, which is this, is equals to 2. So what does this arrangement, this sliding of the box tells you? It tells you that this is nothing but a very simple, a standard sliding window solution, a standard sliding window problem, right? The only thing that you had to do, the only single thing that you had to do is actually transform the question a bit. You didn't actually have to think in terms of meetings and their times. You actually had to think in terms of gaps. So this transformation is literally the only creative thing that this problem required from you, in my opinion, right? So having said this, let's say for a second, let's make why have I erased this? Let's say that our k was something different, right? Our k was, let's say for a second, our k was 3. Okay, our k was 3. So in that scenario, in that case, what would have been different? Let me change colors over here. Let me pick up a different color, right? So in that case, what would have been different? You see, this is gap 1, this is gap 2, this is gap 3, and this is gap 4. Now I know that I can move around 3 meetings. Alright, I can move around 3 meetings. So what I will do is, let's say I move this particular meeting to the very start, or I merge it with the next one. So what happens is, my k is 3, right? I can, sorry, not 3, actually 2. So I have moved one meeting, right? Only one more I can move. So what's going to happen is, this 1 plus 2 is going to become 3, but I can still move one more meeting, right? So what I will do is, I will move this one as well. Now you see what's happening over here is, let's say I have moved the 1 comma 2 box over here. So over here I have g1 plus g2. Okay, over here I have g1 plus g2. Now I still have k equals 1 left. So what I will do is, I will move this particular box as well. Again, see, it doesn't really matter whether you merge it with this one, whether you merge it with this one. At the end of the day, what you're doing is basically g1 plus g2 plus g3 plus g3. So what you're going to have is 4. Sliding window, isn't it? And then what you're going to try to do is, okay, let's not move this particular combination. Let's move the other combination that we have. So let's merge g2, g3, and g4. All right, what I'm really trying to tell you is, your window size, since we are talking about sliding window, your window size is nothing but k plus 1. And this is literally right in front of you. I could have told you at the very beginning of the question, but that would have taught you nothing, exactly nothing, right? So this is how incrementally we observe, we break down the test cases, and then we observe how things are basically happening, right? And one actually, you can say, one very important skill for you to learn from over here is thinking of test cases, right? Thinking of interesting test cases that actually make you understand the problem even better and in depth, right? So since over here k is 1, and our answer is 2. Why our answer is 2? Because the window of 2, as simple as that. So having said this, let's see now how we can take this particular approach into our code. Let me put it over here. Let me put this over here. Perfect. This works. Now, the first thing that I need to do is, let's say I take n as what? I take n as, or maybe when I need n, then I will use. The first thing that I need to do is create the gaps array. Sorry, vector int gaps array. Perfect. Then what I need to do is, I need to iterate over start time and end time. So what I will do is, int n is equals to start time dot size, so that I can iterate over a start time and end time vector at the same time, because both of them have the same size. And I need to consider, I need to think about the gaps considering both the arrays at the same time, right? Okay, so what I will do is, for int I equals 0, I is less than n, I plus plus, I need to see what the ending time of the current event is, right? So end time, I can say end time current, integer end time of current event, it's going to be equals to end time of equals to end time of I, and int start of next event, that is going to be equals to start time of I plus 1. And since I am doing I plus 1, I need to make sure that I iterate till n minus 1 only, right? Makes sense. And what am I going to push inside the gaps array? I'm going to just push back the difference of these two. So n time of the current event, start of the next minus n time of current, basically, isn't it? I could have taken the absolute, but then you can do it this way as well. So the start time of the next event 4 minus the ending time of the current event, which is 2, tells you that there is a gap of 2. Perfect. And what we did was we said कि भाई there can be a situation where your first event does not start at 0, right? So let's have a look. If start time of 0, the first starting time that you have, if it's not equals to 0, if it's not equals to 0, then it's 1 or 2 or any number n. So what you need to push inside gaps is whatever that number is, right? Because that's going to be your gap, start time of 0. Perfect. And similarly, what we observed was that there can be a gap at the end as well, isn't it? Because there can be a situation where when your last event does not end at event time. You know what event time is? It's basically the limit that is given to you. At event time, your event actually ends, and you can no more place any meeting after the event time has elapsed, right? So time if end time of n minus 1, if it's not equals to event time, then what am I going to do? I am going to push back inside of gaps event time minus what? Minus n time of n minus 1. N time of n minus 1. Perfect. This makes a lot of sense. Zabardast. Right. Then what we need to do? So at this point we have the gaps array. Now what we have simply have to do is apply sliding window, right? With window size k plus 1, standard sliding window, right? Nothing new, nothing, literally nothing creative over here, just standard sliding window. So what I will do is I will create an answer which is known as 0, and I will create the initial sliding window. So for int I equals 0, I is less than k plus 1, I plus plus. What I will do is I will say, okay, ans plus equals whatever gaps of I is. Now let's say that over here gaps is 1 to 1, you know, gaps is something like this. So you have gaps array, you have 1 2 1 and 1. All right, there can be a scenario, if you think about it, there can be a scenario where this k plus 1, it's actually larger than the size of gaps, and that scenario can be something like when you have, let's say, what kind of a scenario would be when this k plus 1 exceeds the size of gaps. So let's say you have a number line starting from 0 ending at 10, and then you have just one very large event, so you don't really have any gaps or anything, but then the k is given to you as 5. You see, the k is given to you as 5. So in that scenario, you're going to get an out of bound error over here. So you need to make sure that you do something like this. You need to take the minimum of k plus 1. You need to take the minimum of k plus 1 and gaps dot size. Okay, so this is just a safety measure for you to take care of, right? So this is going to populate for you the initial gaps. Over here we had the kf2, so this is going to populate for me this particular window, right? So at the end of the day, what's going to happen is my I is going to be over here, then I will increment it, then I will increment it, and you see this is where k plus 1 gets over. And when my I reaches this particular position, I'm going to get out of this for loop. Now, the thing is, I could have a greater answer than what the current answer is. For example, I could have had 10 over here, right? What I will do is I will create a temporary variable. So I will create a temporary variable. I will assign it the value of answer, and then I will shrink the window, right? So for int I equals k plus 1, I is less than gaps dot size, whatever is left, I plus plus. And what I need to do is now, okay, so since now this is my window, I need to make sure that this one exits from the window, right? This one is nothing but I minus k minus 1, if you think about it. I minus 2 is this and minus 1 is this, right? So yeah, again purely observation. So what I will do is I will say, okay, temp minus equal gaps of what? Gaps of I minus k minus 1. So this is the element that is exiting my window, and then what's being introduced? Temp plus equal gaps of I, because I'm currently at I, right? Now, and what do I need to do is I need to keep track of whatever is the maximum. So if temp becomes greater than the answer, then you update the answer. At the end, you just return the answer. And let's if I directly submit it, if I directly submit this code, let's see if it passes all the test cases or not. What is happening? Gaps dot size. I think I need to convert this into integer. Let's run this code. Let's not be overconfident and directly submit. Passes the example test cases, and I am very hopeful that it is going to pass all the other ones as well. Yeah, perfect. It gets accepted overall. So now if we think about the time complexity of our code, how much the time complexity is, how much is the space complexity, then we can very clearly see that we are taking a vector of n gaps, and at the worst case, you're going to have n number of gaps, or maybe n minus 1 or n minus 2 number of gaps. So we are taking O of n extra space, and then the time complexity over here is also O of n, because we are doing nothing but we are just doing linear operations, right? So we are literally doing nothing more than linearly iterating over here in this particular for loop, and then in both of these particular for loops. So the time complexity and the space complexity, both of them are O of n. So I hope you found the video helpful. I hope you were able to learn some sort of creativity out of this, and I will see you in the next one. Till then, take care.